In this video we're going to talk about oblique asymptotes, which they're the same thing as slant asymptotes. So you might hear it referred to as a slant or oblique, doesn't matter, they're both the same thing. Okay, and then after I talk about what an oblique asymptote is, we'll do a quick example where we have to find them. So here we're talking about rational polynomials, or rational functions, which is a numerator polynomial divided by some sort of denominator polynomial. Now I could write this as, if I were to divide the, if I were to do the numerator divided by the denominator, I would get some sort of quotient, so a quotient polynomial, and then I would have a remainder polynomial divided by d of x, right? So then I have a quotient and then I'd have a remainder, where the remainder, okay, the degree of the remainder would be less than the degree of the denominator, okay? And so therefore, right, so the degree of the numerator, right, in this fraction over here, the degree of the numerator, which, usually we use n, right, would be less than the degree of the denominator, which is usually m. So, so that means that r of x divided by d of x goes to 0 as x approaches infinity, and then also as x approaches negative infinity. Okay, so therefore f of x approaches q of x as x approaches positive or negative infinity, right? Because before it was q of x plus this extra piece, but that's going to 0, so now it's just q of x. Okay, so q of x, now when q of x is linear, right? So if q of x is something like mx plus b, which will only happen if the degree of the numerator is exactly, so the degree of the numerator here is exactly 1 more than the degree of the denominator, right? And by the way, this will only work if the degree up here is higher than the degree up here, down here, right? You can't do this division otherwise, okay? Or you can't write it like this at least. Okay, so q of x will be linear if the degree of the numerator is exactly 1 more than the degree of the denominator. All right, so if q of x equals mx plus b, or just, in other words, q is linear. If q is linear, then f has a slant asymptote or an oblique asymptote. Then f has an oblique asymptote. Okay, so let's do an example where we have to find this oblique asymptote. Okay, so in this example, first thing you notice that, so up on the top, right, the degree is n, or 2, n equals 2. On the bottom, the degree is 1. Okay, so the highest power of x on the top is 2, highest power of x on the bottom is 1. Okay, so n is more than m. Okay, if you remember back to our rules about horizontal asymptotes, this meant that there was no horizontal asymptote. All right, so when you see that there's no horizontal asymptote, that's when you want to start thinking, well, is there an oblique asymptote? Okay, so no horizontal asymptote, that's when you start questioning, should I look for an oblique asymptote? Okay, so now let's go ahead and get started with trying to find the oblique asymptote of this guy. So what do we want to do? We want to divide, we want to figure out what the quotient and the remainder is. Okay, so let's go ahead and do this using synthetic division. So if I were to do that, first I would write my coefficients for everything on the numerator. So that's 1, -3, and -2. And then over here I would write whatever the opposite sign of what you see. So this is +4, so that would make that -4. Okay, let's go ahead and do our synthetic division. You could do long division, but synthetic division is faster, so that's why I'm doing it. So drop the 1, And then negative 4 times 1 is negative 4. And then add those two, and then you'll get negative 7. And then negative 4 times negative 7 is positive 28. Okay, and then let's add those two, and you get 26. Okay, so this synthetic division result is basically, what is it? Let's see, this is x, so that's 1x minus 7, and then this is the remainder. Okay, so f of x can be rewritten as x minus 7 plus 26 over x plus 4. Okay, so I just rewrote f of x. I didn't change, this is, oops, sorry, let's see. This is the same as this. This is the same as this. Okay, now when x goes to infinity, this zeroes out. Okay, so you're left with just this. So that is your oblique asymptote. When x goes to positive or negative infinity, I should have said. So this here is your oblique asymptote. So you would say, y equal to x minus 7 is the oblique asymptote. In the next video, I'm going to give a graphing example where we need to graph a rational function, and we're going to have to graph an oblique asymptote. So it'll give you a better idea of what this means in terms of what your graph will look like.